Hello, everyone. This is Dr. Sri Banerjee, and thank you for having me in this conference this year. Today, I will be talking about using random forests for improved health outcomes and social change. Before I get started, I'll tell you a little bit about myself. I've been in public health for the last 20 years and have been working on techniques over the years in order to handle nationally representative data sets. And so currently I'm a core faculty member at the Walden University School of Health Sciences, and I teach doctoral level students and am engaged actively in statistical research. So let's go ahead and get started. Today, in roughly the next 10 minutes, I will be talking about the different types of machine learning categories and where random forest fits in. So this is a very short amount of time to talk about all of these aspects, but what I will do is I will show you some of the theoretical underpinnings of random forest, which is a type of supervised machine learning, and demonstrate how in real time how a nationally representative data set can be used to study and understand some of the social problems better. Here's the abstract just in case you didn't get a chance to look at it. So the analysis of survey data is not something that's new or unique to machine learning. The nationally representative data sets that the Centers for Disease Control holds, a lot of these are being actively, continuously collected, and surveillance measures are being actively conducted. So with all of this massive data coming in, what are some techniques that we can use to be able to handle all of these data sets? So there's specific types of considerations that are needed in survey data sets. So these are some of them. So one of the ones that I will be focusing on in this talk is more the National Health and Nutrition Examination Survey. So the specific problem that I wanted to address here is trying to understand depression. So why did I select depression? Mental health is one of those areas that is a common factor for certain social problems. So in terms of depression causing not only mental health issues, but also certain social health and physical health ramifications which come about with that. So understanding this subpopulation will help us destigmatize and really be able to provide the help that is needed for individuals and that are going through depression. So this is one example. Depression is one example of an area that can really benefit from the tools that are available to us through random forest and other machine learning techniques. Especially, I'll show you specific measures that are needed. So just a little bit about this. If you see here, it's completely different from the traditional parametric statistics. We harness in machine learning the computational power of faster computers that are over the years developing. And so the widespread availability of faster computers has made machine learning possible and feasible at the individual level. So this is showing how these are just different examples of how the learning supervised learning setup makes sense. And if you want to, you can go over this a little bit more, but there's roughly usually a training data set and then a test data set. So typically you split the data set into first training, and then in a separate proportion you test your model. So a lot of these use CART techniques. The main uh, technique that is used in terms of deriving random forest is a specific type of regression. And this is being largely used in cancer studies and coronary heart disease, but also being applied to other areas as we speak. So, why is CART receiving more attention? Well, there's of course availability of huge data sets requiring analysis, but application of regression trees, you have a need to automate or accelerate improving analysis process. So data mining is so important now that these will really be a lot more available and a lot more techniques will come about from this. So let's take a look at some of the random forest applications. So all sorts of, there's an example of the heart attack being diagnosed appropriately from EKGs, chest pain, elevation of enzymes. So these things are a lot more improved in random forest applications than in parametrically derived algorithms. So in this, myself and other researchers, we looked at the National Health and Nutrition Examination Survey. Of course, this is 5,000 individuals are surveyed each year, and we looked at a couple of cycles between 2005 and 2010. So here were the results, and I know this slide is a bit busy, but if you look closely, we did have significance in many of these factors, including, I want to bring to your attention at the very bottom, the C-reactive protein was significant with hypertension. So this is something that shows that the relationship between hypertension and a lot of these factors. But what is more interesting and more important to note, it's a bit busy, but it really goes into the heart of our study that was completed. So again, just to remind you, the main focus of the study was finding a connection between hypertension and depression on a cross-sectional level, but additionally to see if there was a stronger connection between hypertension and depression in those individuals that had elevated C-reactive protein. Now, C-reactive protein is an inflammatory marker, and so we wanted to see the actual effect of C-reactive protein, this inflammatory biomarker. So then that was done conducting logistic regression, and we did find effect modification, and C-reactive protein does in fact modify the effect of hypertension on depression. So the next thing that we wanted to see is at what level is C-reactive protein playing a role in depression. So if we were to create a prediction score for depression, then at that level would C-reactive protein be elevated. So that's what we wanted to see. So in summary, what we were intending to do is look at the relative importance of different variables. And so by looking at that, we were able to determine that C-reactive protein is in fact important in the risk prediction of depression. As you can probably determine in the machine learning part of this, we were able to determine the relative importance. So in conclusion, we have here a demonstration of an example of how machine learning can be applied in the National Health and Nutrition Examination Survey, and how the relative. In this example, of course, this random forest model, you can see the relative importance according to the mean decrease in Gini. And these are all of the predictors that were within the model for depression. And so as you can see, there's about 11 predictors. And so out of these, you can see CHF, congestive heart failure, is at the bottom of the list, while age, ethnicity, smoking status, and the two variables that we're really interested in trying to find out is, of course, hypertension. And as you can see here, hypertension is very much connected. And when we included C-reactive protein into this model, what happened was it was a bit more important than hypertension. So here, we were able to incorporate all of this. So this is how that works. So the next thing that we were looking at is trying to make sense of all of this and how the original regression model, which was derived from a frequentist approach, we can use that to combine what we found here in order to find out a more complete picture of what is going on. So in conclusion, artificial intelligence can indeed be harnessed in order to solve complex issues. And what our aim here is to understand precisely some of these common factors which combine mental, physical, and social health in order to create changes in policy and changes in how medicine and mental health and all of these are served to the community. Thank you for listening, and if you have any questions, please do not hesitate to contact me. I gave you my email information. So thank you for listening. The importance portion of the random forest can be used to understand the relative importance of different risk factors, which is not something that can be easily determined from just logistic regression alone. And in other levels, we can actually go further and create certain programs based on the risk prediction that comes about through any sort of machine learning, including random forest, and some more robust ensemble machine learning and deep learning techniques that can further enhance the robustness of the risk prediction. But overall, our model was robust. There was not a high percentage of error, and so this was, in comparison to other machine learning models, this was the most optimal model for this sort of technique. So I hope this has really enhanced your learning of machine learning, and thank you for listening.